Okay, so here's example 2 of using the alternate definition of the derivative. So let's go ahead and use that to find g primed of x if g of x equals x minus 1 over x plus 2. Okay, so we have g primed of x equals the limits as t approaches x of g of t minus g of x divided by t minus x. Alright, so this equals the limit as t approaches x of, if g of x is x minus 1 over x plus 2, then g of t is t minus 1 over t plus 2. So this is going to be t minus 1 and then t plus 2. And then we have minus g of x, which we know is just x minus 1 over x plus 2. And then all divided by t minus x. Okay, so right away we can see that this is pretty much simpler than it would be if we used the original definition, because instead of t minus 1 over t plus 2, we would have x plus h minus 1 over x plus h plus 2, and that would be kind of a mess, especially for this next step. So here, for the next step, again, we can ignore the big bottom and just get a least common denominator, or let's just do what we've been doing and see, here's t plus 2, here's x plus 2, so let's multiply the big top by t plus 2, x plus 2, and the big bottom by the same thing. Alright, and then parentheses here, be very careful about that. And then what we have is equals limit as t approaches x of t minus 1 over t plus 2 times t plus 2 x plus 2 minus x minus 1 over x plus 2 times t plus 2 x plus 2. And then all that's divided by t minus x times t plus 2x plus 2. Okay, so let's go ahead and see what we can simplify here. So t minus 1 over t plus 2, and then times t plus 2, so those are going to cancel. Wonderful. X minus 1 over x plus 2, and then times this x plus 2, so these guys cancel. Alright, so now what we're left with is t minus 1, this quantity times x plus 2, and then x minus 1, this quantity times the quantity t plus 2. So we got to be very careful about that. So let's go ahead and rewrite all that up here at the top. So this is going to equal the limit as t approaches x of, just to recap, t minus 1 x plus 2 minus x minus 1 t plus 2. So that's t minus 1 x plus 2 minus x minus 1 t plus 2. Alright, and then on the bottom we still have the same stuff, t minus x times t plus 2 times x plus 2. Alright, so for this next step, we're going to FOIL these two guys and also these two guys here. So we have to be very careful, actually. Why do we have to be careful? Well, first of all, this equals the limit as t approaches x of what? So what we have to be careful about is when we subtract this stuff here. But for now, let's do this first term here. So when we FOIL, we have first gives us tx, outer is plus 2t, inner is minus 1x, or in other words, just minus x, and then last is minus 1 times plus 2 gives us minus 2. Alright, now we have to be careful because we have minus all this stuff here. So what we really should say is, let's go ahead and do this. We'll put red brackets around this. Alright, so now inside of these red brackets we're going to FOIL. So first gives us tx, or xt, but it's the same thing. Outer is plus 2x, and then inner is minus t, and then last gives us minus 2. Okay? So that's what's going on here. So we want to be very, very careful about that. That we make sure we're careful with this minus sign here. So we got to have these red brackets out here. And then on the bottom we still have t minus x, t plus 2, x plus 2. Alright, now let's go ahead and drop these brackets. So to do that we have to distribute this minus sign. So remember, this minus sign is like minus 1 times all this stuff here. So what this is going to become is equals limit as t approaches x of tx plus 2t minus x minus 2. This is minus tx minus 2x and then plus t and then plus 2. And the bottom is still the same for now. Okay, so we've got that going on so far. So now we're going to see what we can cancel here. So here's a tx minus tx, so those are going to cancel. That's good. What else? Here's minus 2, and then here's a plus 2. Those cancel. And now nothing else really cancels, but we can start combining things. So here's a plus 2t, and then plus another t. Okay, so that's going to be 3t, and then here's minus x minus 2x, so that's minus 3x. So then what we have here is this equals the limit as t approaches x of 2t plus t is 3t, and then minus x minus 2x gives us minus 3x. And then on the bottom we still have the same stuff. T minus x, t plus 2, x plus 2. Okay, so now notice on the top we have this common factor of 3. Okay, here's 3t minus 3x. So let's go ahead and factor out the 3 from everything here. So we're going to end up with this. Okay. So now this 3 we can just pull out of the whole limit. So let's go ahead and do that here in this step, just to save space. So this is going to equal 3, and we can pull that out. Alright, now notice here, here's t minus x on the top, and here's a t minus x on the bottom. And that's good because now we can cancel them. And remember, that's what we want to do, because if we take a limit as t approaches x, then we have a 0 on the bottom and a 0 on the top. But we want to get rid of that. So now we can do that by canceling these. Okay, so now this equals 3 times the limit as t approaches x of what's left on top. Well, just a 1, because we canceled everything. Oops. So this is going to be 1 times, or divided by t plus 2 times x plus 2. Alright, now we can go ahead and do direct substitution. So when we do that, we're going to have 3 times, we're taking a limit as t approaches x, so replace every t with an x. So this is just going to be 1 over x plus 2 times this x plus 2 just stays as x plus 2. Alright, so then what we have is 3 over x plus 2 quantity squared. And that's our derivative. That's g primed of x. So notice here, the algebra maybe got a little messy because we had x's and t's flying around all over the place here, but I do think it's a little bit simpler than it would be if we used the original definition where we had g of x plus h instead of g of t. So I actually kind of encourage you to go ahead and try that, and you'll see that in this second step here you would have x plus h minus 1 over x plus h plus 2. Go ahead and try that and see which one you think might be simpler. So, of course, you'll end up with the same answer, right, because it's still the derivative. It's just, this is just an alternate definition of the same thing. So if everything goes well, you'll get the same answer. But I do think this one is a little bit simpler, this method.